Hey guys, this is Miss Mo. This is for section 9.5. In section 9.5, we finally get to start using some shortcuts to find the derivative. And remember, when I say derivative, that's just another word for slope, average rate of change, instantaneous change, velocity, blah, 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 blah. So derivative is just another way to find slope. Okay, so we're going to be looking at these 9.5 shortcuts, okay? And instead of using all those crazy formulas, you know, with the F and the H and the all the limits and the F of parentheses, all those crazy formulas from 9.4, finally in 9.5, we just get to use tricks. So in 9.5, the very first trick we learn is that if you, over here on the top right, it says derivative slope of a number, which is a constant, and that's just equal to 0. So anytime you have just a number, the slope is 0. So if we look at this part A, it says f of x equals -1, and then what's f prime x? Well, that f prime, if we look down here at the right, that's the same thing as finding the slope or the derivative. So we're just finding the derivative. And up here it says the derivative of a number is just 0. So the derivative of just this number is 0. Woohoo! And we could do that crazy formula from 9.4 to prove this, but hopefully you believe me. Okay, let's look at this next sucker, part B. The shortcut to finding the derivative of this, instead of using those crazy huge formulas, is to use this smaller formula, derivative slope of x to a number. What you do is you take your exponent and you bring it down in front. So I have an exponent of 10. I'm going to bring it down in front. So I'm going to have 10x, and then let's see what happens to that exponent. It says your exponent decreases by 1. So instead of an exponent of 10, we have 9. And hey, baby, you just found the derivative. And this weird symbol, dy over dx, that's just another synonym for slope or derivative. Okay, let's look at part C. Same thing. You take the exponent that's in the air, bring it down in front, and you get 12x, but then you subtract 1 from the exponent, or you decrease the exponent by 1, and you get 12 minus 1, 11. Hey, baby, and that's d over dx, and that's the same thing as, guess what? Slope and derivative. So there are all these different symbols, all these different words, but they always just mean the slope. Okay, let's look at part D. It says x to the -2. Uh-oh, trickery dickery. Well, first we're gonna pull that -2 in front. -2. X to the decrease 1. So we have to take this exponent of -2 and subtract 1. That does not make -1. If I use my calculator, I'm gonna say -2 with the negative button at the very bottom. And then for the -1, I'm going to use the minus over here on the right by the plus, -1. And I get -3. Hey, guess what? That's your y-intercept. Just kidding. It's your slope. It's your derivative. Woohoo. Okay, let's go to part E. It says g of x equals x to the 8 over 5. Oh, that's terrifying. And then it says g prime of x. Well, g prime of x is the same thing as f prime of x or r prime of x or m prime of x. Whatever. We found the derivative. Okay. So we're going to bring this 8 over 5 down in front. Then we're going to rewrite this letter x. Then we have to subtract 1 from the exponent. And no, 8 minus 1 is not 7. Well, it is, but not when that 8 is over a 5. So we have to come up with a common denominator. If you want to, you can just try whipping it in your calculator. Like open parentheses, 8 divided by 5, close parentheses, minus 1, because we're supposed to be subtracting 1. And we get 0.6, but then press math, enter, enter. Math, enter, enter. 3 over 5, yeah. So in this homework, if you start with a fraction in the air, you better end with a fraction in the air. So that's why I did not type this 0.6, because the homework might count it wrong. So if I would have started with decimals in my problem, then I could end with decimals in my problem. But since I started with fractions, I have to end with fractions. That's a weird rule. Okay, so this was our derivative, or our slope. And if you want to know how to do the subtraction with the common denominator, I said 8 over 5 minus 1, but then I needed a denominator of 5, so I multiplied by pi over 5. Yay. And that makes 8 over 5 minus 1 times 5. 5 over 1 times 5. 5. And then when you subtract fractions, you subtract the top, 8 minus 5, 3. And you keep the bottom the same, 5. So either you do it by hand or you do it in your calculator. I'm desperate. Okay. Hey, let's move on. Let's look at this sucker. Oh, what? Okay, so it looks like we got a division. Weird. Okay, we're going to have to change that. This is some of the old math that we need to remember. So look at your 9.5 tricks. And we're looking at this part that says 1 over x to the 6th is the same thing as x to the negative 6. Or 1 over x to anything is x to the negative, whatever that exponent was. We were supposed to learn that in the class before this. So if you have a letter x in the bottom, and there's just one of them, and it has an exponent, instead, you can just say that letter x to that negative exponent, and you stop dealing with fractions and that big old 1 on top. So I'm going to say this is the same as y equals x to the negative exponent, negative 7. And then I haven't taken the derivative yet. All I've done is rewrite it because I didn't like that weird division bar. And we don't know how to deal with a division bar yet. Okay, so now we use that power rule where we take that negative 7, we bring it down in front. This is the same thing we've been doing. I just used the word power and you panicked. Okay, so you bring the negative 7 down in front, rewrite that letter x, and then if I take this negative 7 and subtract 1, it's not negative 6. So I have to subtract 1 from this exponent. And that actually makes negative 8. Woohoo! Okay, the only thing is, since I started with a fraction, your homework might not take this as your answer. They might want you to put it back into a fraction. So try and see if your homework will take this with the negative exponent. And if it doesn't, we can just throw it back in a fraction, as in whatever has the negative exponent, x. That's what you put in the bottom, but you make it positive, so x to the 8. And that's because of that rule that says, that old math that says x to a negative number is the same thing as a fraction with that x in the positive number, exponent. Okay, so the x to the negative 8 goes in the bottom because it has a negative exponent. Okay, but then this negative 7 doesn't have a negative exponent. He has like a +1 exponent. So he's going to go in the top. So the only thing that goes in that bottom is whatever is directly attached to this negative exponent, x. And then this -7, he doesn't have a negative exponent, so he just goes on top. Hey, this is the derivative or our slope. Okay, let's keep going. It's pretty much this over and over in this section. We just try and freak you out every once in a while. Okay, so let's look at this. G, f of x equals 8x to the 9. So we're going to do the same thing. We're going to take this 9 and we're going to pull it down in front. But when I pull it down in front, I don't write 98 because of that 8 that was already there. When I pull that 9 down in front, it gets multiplied. So when you pull that 9 down in front, you put a little multiply dot. Or you can actually multiply it. And then x to the 9 minus 1 is 8. And then we just figure out what 9 times 8 is. So 9 times 8 was, oh gosh, 9, how do I do this? 8, 72? I think it is. 72, x to the 8. Hey, baby, that's the derivative, or the slope. And if you notice at all these examples, I'm giving you different symbols. Like on the one we just did, it said f prime of x. The one underneath it says d over dx. But they all mean the same thing, derivative. So on your homework, you might see this symbol, this symbol, this symbol, this, all of these symbols and all of these words mean take the slope. Okay. For h, pretty much the same thing that we just did. You take that 8, bring it down in front. 8, but then instead of writing 80 and then the 7 that was already there, like this, 87, I gotta put like a little multiply dot. Okay. So pull the 8 down in front. There's already a 7 there. X to the subtract 1 from the air. 8 minus 1, 7. And then figure out what 8 times 7 is. I think it's 56. I'm not good at counting. 56x to the 7. That represents the derivative or the slope. And if you're wondering, how the heck can these represent a slope? I thought slope was rise over run. Well, in a second, I'm going to give you what x equals, and then we'll take that number and plug it in for these x's, and that will give me just a whole number, as in rise over run. So this isn't quite our slope yet. We still have to plug in our x value if they gave us one. Okay, let's look at I. Oh, gatos, this looks crazy. Okay, so I'm gonna take this 5, but when I pull it down in front, I don't put it underneath with the 20. I put it just on the top. Yeah. So I pull that 5 down in front, and I have 5x to the, we're still over 20, so nothing has happened with the 20. It's okay, don't panic. Okay, so pull the 5 down in front of the x, then subtract 1 from this exponent. 5 minus 1, 4. Then the very last thing to do is try and reduce this 5 and 20. I think you can reduce them by 5, so let's do it. You get x to the 4, because that cankles. And then 20 divided by 5 is just a big fat 4. Bam! Derivative. Slope. Okay, another one. This one's a little bit more because it has a plus sign, but don't panic. We're just going to do everything we've been doing twice in a row. Okay, so for this next sucker, we're going to take the 3 and pull it down in front, but we're not going to write -2, then a 3. We have to use a multiply dot. Okay, so bring the 3 down in front. It multiplies. And then you have t to the subtract 1 from the exponent. 3 minus 1 is 2. Don't panic. It's okay that it's a t. Nobody cares. It's just another thing. It's just like the letter x. Don't panic. Okay. Now let's look at this lonely t. This one's rough, okay? Okay, I'm just gonna draw it real big right here because you might not see it when it's tiny. Okay, so we're trying to take the derivative of just this letter T. Well, first I need to know what number's in front of it and what number's in the air. Well, the number in front of it is my good friend 1. Hey. And the number in the air is a good friend 1 too. So this is the same thing as 1t to the 1. Okay, now let's take the derivative of this. You're gonna take this take this exponent 1, bring it down and multiply it, and you get not 1, 1. You have to put that multiply dot. Remember, like we just did? Okay, so 1 times 1, t to the, if you subtract 1 from this exponent, you get a 0. And I don't think I put this on that old math to remember, but any letter to a 0 power is just 1, as in, it just goes away. Yeah, so any letter to the 0 power, it just goes away because it technically just means 1. And then all we have left over is 1 times 1 or just 1. So that means no matter what letter you have, if you're just trying to find the derivative of A, it's 1. The derivative of Y, it's 1. The derivative of X, it's 1. The derivative of F, no, let's not use that. That's going to be confusing. M, it's 1. So anytime you just have a good old naked letter, it's just 1. If there were numbers in front of these letters, then that would be different. But we're not ready for that. Okay, so anyway, the whole point is, if we look at these top right tricks, it covers what I just said. The derivative of just X is 1. Oh, okay. So the derivative of just T is 1. Oh, and there was a plus sign, so let me put a plus sign in between these. Okay, now let's just multiply it and maybe not have it so spaced apart. Negative 2 times 3 is negative 6. T squared plus 1. Hey, baby. That's our derivative or our slope. Okay, let's go again. Whoa, this one looks crazy. It says d over dx, but look, d over dx just means slope, derivative. Okay. And then it's got some parentheses, but don't panic. Those parentheses are just to separate it from that weird d dx. Okay, so all we have to do is take the derivative. Okay, well, I know that the derivative of just a number or a constant, like this number 3, the derivative of or the slope of a number or a constant is just 0. So this 3, the derivative of him is just plus 0. And no, we don't have to write that down, but I'm just doing it. Okay, now let's look at this 5x. This has a pretend 1 in the air. And when I take that 1 and bring it down, I do not write 51. I write by time 1. And then x, and then subtract 1 from your exponent. Well, if I subtract 1 from that exponent of 1, I just get 0. And then what did I just say about anything with a x to the 0 power? It's just equal to 1. And it ends up just going away. Okay, so anything to the 0 power just goes away. So this x to the 0 is gonna go away. But not the 5, because the 5 has an exponent. It's like a little pretend baby 1. Yeah, okay. Anyway, so all we have left is 5 times 1. 5. Then the plus 0, yeah, that doesn't affect me. So my derivative or my slope is just 5. And that kind of makes sense. Not really, but let me tell you. Okay, this 5x plus 3, if I call that y equals 5x plus 3, Remember that this is another way of saying mx plus b, and holy poop, your slope is 5. Yeah, so derivative and slope are the same thing. On this one, it was easy to tell because the equation looked like mx plus b. But on L, it ain't no mx plus b, so I can't, try and make this connection with you. Darn. Let's go to L. First, I'm going to take this -4 and bring it down in front with the 9, but not -49. What do I put? A multiply dot. Okay, so bring down the -4, write down your x, then subtract 1 from your exponent. What's -4 minus 1? It gets even more negativer, and I think you get -5. Okay, then we have a -8. -8. But then you have to bring his exponent down in front. But that doesn't make 8 minus 1. That makes 8 times -1. And I'm just going to use a parentheses right here instead of a dot because it just looks prettier. Okay, and then x to the, subtract 1 from this exponent. It does not make 0. It makes an even crazier negative, as in -2. Okay, now we're just going to clean it up by doing the little multiply stuff. -4 times 9 is -36. X to the -5. Then on this next one, make sure you multiply the whole -8 and the -1. So make sure you multiply that negative that was on the 8 with this -1. And that makes a +8. And then x to the -2. Hey, and check yourself. We started with negative exponents, so it's okay that we end with negative exponents. Yay. If we would have started with a... where did we do it? If we would have started with a... I don't even know what I'm saying. Oh, fraction? We might have to put our answer back in a fraction, depending on the homework. Okay, let's see look at this letter M. It's pretty much the same thing. It has this weird DDU, but hey, guess what? That still means derivative. We have so many different symbols because derivatives can be applied to math, economics, chemistry, biology, physics, it just goes on. So every subject has their own set of symbols. That's why we're giving you all of them. Okay, so there's a U, but don't panic. It's just like an X. Okay, let's go. We're going to take this 0.8 that's in the air and bring it down in front. But again, we're not going to write 0.8. That looks weird. And I think I'm just going to draw some parentheses instead of a dot, because I might get confused with all the dots. Okay, then we have the letter U. Then we have to take 0.8 in the air and subtract 1. 0.8 in the air, subtract 1. -0.2. -0.2. Okay, now let's look at this next piece. I'm going to do it in a different color because it might get crazy. Okay, I'm going to take this 3.4. That's a horrible color. I'm going to throw it away. Okay, I'm going to take this 3.4 and bring it down in front and multiply. That's sparkly, also a horrible color. Okay, and when I bring it down and multiply, I don't write minus 3.4. I have to write minus 2 times 3.4. So I'm just going to put that 3.4 in parentheses because if I put another dot, it's going to confuse me. And then you subtract 1 from the exponent. 3.4 minus 1, 2.4. Yes. Okay, the very last thing is we're just going to do this multiply business and we'll be finished. So 3 times 0.8 is 2.4. U to the, don't mess with that exponent you wrote down, minus, let's see, -2 times 3.4 is -6.8. So I already have my minus, and then 6.8 u to the 2.4. Woohoo! Okay, so that represents our slope or our derivative. I'm gonna take a break. Maybe.